So if you have a group of related data that's organized in a table format, you should automatically consider using a two-dimensional array. Two-dimensional arrays use the same basic syntax as a one-dimensional array, except for it has a second pair of brackets, right? So a one-dimensional array you would declare like this. And for a two-dimensional array, you just use this double bracket notation, right? The first index identifies the row, and the second index identifies the column position within the row. So it's basically an array of arrays. So for example, here's a 2-row by 3-column array named X, right? And you can see here's the values. This is the column index, and this is the row. So the first position, 0, is going to point to which column we are in. So this 0, 0 is going to be here, right? This 0, 1 is going to be here, and this 0, 2 is going to be here. Likewise, this x1, 0 is going to be this position, 1, 1 is going to be here, and 1, 2 is going to be here, right? So the two positionings correspond to each other, right? And so it can get a little, complicated. But it's really not. If you just think about it as rows and then the columns, it's easy to figure it out. Now, as with one-dimensional arrays, there are two ways to assign values into a two-dimensional array. You can either use the initializer as such or an assignment statement like this, right? So the key here is to note that you got to use these braces inside of braces, right? Because it's an array of arrays. So this is array number 1. And this is array number 2. So we are initializing, array 0 to be this array, and array 1 to be this array. Okay, so that's the notation that you're going to use. Now with the declaration, you have to specify the size of the columns and the rows. Right? Notice how we didn't have to do that for our initializer, and we didn't have to use the keyword new, right? So the notation can get a little squirrely because you're bouncing between, okay, well, I have to use new now with a declaration, but I don't have to use a new with initialization. So it can be a struggle, and it's going to generate errors. You just have to be aware and be able to read your console and read the errors that get generated. But know that with initialization, you don't have to use the keyword new. The compiler will automatically throw that in there for you. So the following code fragment declares and creates the X array in one statement and assigns values to X's elements in a separate statement. So let's walk through it. So here we can see we're declaring and creating a 2-row by 3-column array. And then here is where we're actually assigning the value to it at row I in column J. But notice here that we're using row 0 as the determination for which the length of it, right? Well, if you think about it, in our array, which is a 2 by 3, so let me see if I can draw this better here, right? All right, we've got 2 rows and 3 columns. Well, it doesn't really matter which row we pick, whether we pick row 1 or row 2, because they're going to be the same. They're both 3 long. So it's really by convention that we use row 0 for this. Okay, it doesn't matter, but if all things are equal, then just use the lowest number possible. So in this case, it's 0. We're going to use row 0 as whatever thing we're going to get our length for our array from. So here you can see the 2D array in code. Just like the previous screen, right? Everything's the same here. So what happens when we execute it? Well, if we play it, you can see here, enter a value for row 0, column 0. Okay, well, I'm going to enter 1, 2, 3, 4, 5, 6. That's all the program does, right? We're entering the array, and then we're not actually doing anything with it. But you can see how we are declaring and creating the array on this line, and we are not assigning it any values until this line. That's the whole point of this demo. So the bottom line is that in order to loop through the rows in a two-dimensional array, use the array name dot length, right? Again, that's the rows. And to loop through the elements within those particular rows, use the first row's length, like such, right? And here's a graphical depiction of it to kind of help you figure it out. So we normally think of it like a table, like this, but it's actually, we have an object that's pointing to an array, and each of these elements in the array contains its own array. So it's helpful to think about it like a table, but this is really the representation of it. So if you think about it like this, it'll help you because now this dot length is 2, and you can see that this dot length is 3, but you can see that they're both the same, so it really doesn't matter. So hopefully that helps you figure out the two-dimensional arrays because they can get kind of tricky sometimes. So we're going to look at a demo of a two-dimensional array, but here is the basically the concept of what it is. It's going to be we're going to use a two-dimensional array to store the data of the flight times between two cities. So, you know, if you're old like me, you remember looking at a paper map, and they would have often these columns and rows set up like this for mileage between cities. So if you were driving, you could see that getting from, you know, Wichita to Topeka would take 22, you know, would be like 100 miles or whatever. So, but this is flying. So this chart right here gives us the information that we need. And obviously this middle row right here is zeros because Wichita to Wichita 0 and Topeka to Topeka 0, so on and so forth. But so anyway, this program is going to contain a prompt for flight time that's going to prompt a user for which departure city and then what arrival a city, and that's going to give us this value, right? So let's go ahead and take a look at that program in action. So here you can see our flight times driver, and in it we are declaring a double array, right, of flight times, and you can see that this data is the same data that we had on the previous slide. Here we have our string of cities, right, and it's an array, and we've got our 5 cities there, and we have flight times is equal to this new flight times object where we pass in the flight times and the cities. So we're passing in this parameter and we're passing in this parameter, and then we're going to print out a couple things. We're going to say, hey, what are the flight times, right? And so we've got some methods associated with this class. So let's go take a look at the flight times class. So here we have the flight times class, and in it we have a private double array of integer called flight times and a string, so just like we're passing into it. And so here our flight times is our constructor, right? And we're saying our constructor is, we're just setting whatever we pass into our local, our internal variables. And then so here is where prompt for flight time, this is going to prompt the user to enter some information. So we got a standard scanner, and we're going to create these variables called departure and destination. And so we're going to print out for our cities.length, we're going to print out all of our cities. And we're going to offset it by 1 just to make it convenient to the user, right? So we're going to say, hey, go ahead and enter the value of the city. And then we're going to subtract that 1 down here so the user doesn't have to think about starting at 0, because that's kind of a not normal way to think about things, right? And so that is going to print out the flight times for the user. So, and here's the other function that we're going to display, and that's just a function that displays the flight times. And so here you can see we've got a final constant, so we got a format string. So we're going to print out a item that has 5 spaces, that's a string, and then another one that's 5 spaces that has a decimal, right, or a integer digit. And so the rest of this you can figure out on your own, but basically it's just printing this table off in rows and columns. So let's go ahead and run this. Okay, so here it says flight times for Kansmo Airlines, right? And we got our table, and it says enter departure city's number. Well, let's go from Topeka to Columbus. And there you go, flight time 25 minutes. And so if you look at Topeka, we go across to Columbus, you can see 25 minutes right there. So that's the program in action. That's how you could use a double array. You can use a double array for a lot of things. They're really powerful, and some other programming languages have different ways of handling it, but this is pretty similar to C++ as well. So it's definitely worthwhile to pay attention to double arrays and know how to implement them and use them. So not only can we use an array to store objects that are primitive types, but we can also use arrays to store reference objects, right? So non-primitive. So let's go ahead and take a look at that. So suppose you need to keep track of sales for a particular sales clerk in a department store, right? So in the following clerks array, each element holds a reference to a sales clerk object. Each sales clerk object holds a sales clerk's name and total sales for that clerk. So if clerk Derek sells 2 items for $55.45 and $22.01, then we want to store the cumulative result of all of his sales. So it would be $77.46 for his total sales. So this is kind of what that would look like, right? We have this array called clerks, and it's going to be an array of sales clerk objects. So clerk 0 is going to be a clerk, and clerk 1 is going to be a clerk, and clerk 2 is going to be a clerk, and so on and so forth, right? So let's take a look at this in code and see how we can use the array to store our array objects. So here we have our sales clerk program. So it consists of 3 files. We have a driver, which is going to drive the whole thing, of course. We have a sales clerks object, which stores names and sales for sales clerks, right? And then we have the sale clerk object itself. So we're going to go start at the bottom. We're going to look at the sale clerk, and it basically just has a name and sales, and that's it, right? And some getters and setters. And when we adjust sales, we pass in the sale amount, and it's going to adjust that clerk's sales. Then we have the sales clerks class, which stores an array of clerks, and then we keep track of the number of filled elements, right? So for here's our initializer, we're going to pass in an int, and that's going to tell us how many sales clerks we're working with. Then we have this function called add sale, where we pass in the clerk's name and we pass in the amount. And this is where we actually start getting into some input validation, right? So here we're saying, okay, we're going to add a sale, and we're going to pass in a clerk's name. And if this clerk index, or if find clerk returns -1, which means the name isn't already in the list, well, then it's going to create a new one, right? Otherwise, it's going to adjust the sale of the current clerk. So if this says, okay, the clerk's name that you put in is at position 2, well, then we're just going to update the position. But otherwise, if it's not, then we need to add the clerk to the list, right? So another thing that's interesting that this does is that if the number of elements is equal to the length of the clerk's object, it says, hey, you know what? We need to increase our capacity. So if you look at this double length function, our sales clerk is going to be, we're going to create a new array, doubling the length of it from our current sales clerk's array. Then we're going to use this array copy method, which is built into Java. And we're passing in the array that we want to copy at the starting index. And we're passing in the clerks 2. We're passing in the new array that we want to copy it into at its starting index. And we're passing in the number of items that we're copying over. Once we have that array created and copied, so we're creating this new array, then we need to update our reference, because our sales clerk doesn't know anything about this clerks 2, so we are assigning clerks to point to this new clerk address. And so now clerks is double the length, and it has its original entries. So that's kind of neat how that does that, okay? What other methods do we have in here? We have add sale, so we just talked about that. So if the clerk doesn't already exist, Then we're going to create a new one, and if the array is filled, then we're going to create a new array, doubling the size, copying all the old values into the new array, so that way we can add a new clerk, right? And then we've got dump data, which is just going to print out all of the data. We've got find clerk, which is going to do that sequential search that we talked about. It's going to look through all of the elements, all the filled elements, right? So we're keeping track of, hey, we've put 7 guys or 7 people in this array, only search through the first 7, right? Because, you know, maybe 12 through 14 are empty, so on and so forth, right? So that's the sales clerk class. So now we have this driver that's going to say, hey, go ahead and create a new array, which is going to ask for how much to put in, and then we're going to run it and update some information. So let's go ahead and take it for a spin, right? So let me clear it out again. So we have starting from a fresh page. All right, so enter clerk's name. We're going to enter Corey, right? Enter sale amount, $10. Enter clerk's name. We'll say Bob, right? He's got $15. We'll do Corey again with $17.50. We'll do Bob again with $1.99, right? And we'll do Corey again with $100 because I'm awesome, right? And oh, see, I made a mistake because there's no input validation. So $100 has $100. That's gonna be interesting. We'll do Corey again with, we'll just say $50. 50.01, right? All right, and we're gonna enter Q to quit. So then after we execute, when we're done with the program, it performs a dump. And so you can see it totaled up all of my sales and it totaled up Bob's sales and so on and so forth. So that shows you a lot of the things we talked about in dealing with the arrays being executed, right? So if we walk through this line by line, it starts off creating this clerks object with reserving 2 people in the array. So once I created that 3rd person, guess what? The size of our array was now 4 because of that double method. So I recommend taking a look through the code and seeing how it all works, because it will really, once you start reading the code and going line by line, it will help you understand it. But this just shows you that you can use an array to contain and handle objects just like you can primitive data. So it's finally time to talk about our last topic for this group of videos, and that's the for each loop. And the for each loop is a really, really nice convenience function that's been added into the language that didn't exist when I first started, but once it was there, it's tremendously helpful in doing some easy things if you don't have to do tracking of indexes. So what is it? Before I get ahead of myself, let's actually talk about what it is. So a for each loop is an alternative to the traditional loop, and it's great when you want to iterate through all of an array's elements, but you don't know or care where particular elements are located. So here's the basic syntax, right? So you're going to have for the element type and the element reference. So say this is going to be, if I can find my pen, say it's going to be an int, right? So say we've got an array of ints. So this is going to be for int I in array, we're going to say, you know, it was called int array, right? It's going to loop through each one of those items, and I is going to be the variable that you're going to use to reference each element, okay? So what you're going to do is when you're going to read it, you're going to say for each element in array. So for each I in int array, do the following, okay? So let's take a look at this in actual functionality or whatever in an example. So here's a for each loop example that's going to go through all of the prime numbers that we've put in. So we've got 2, 3, 5, 7, 11, and 13, right? So for p in primes, print out p. It's that easy. You don't have to say for int I equals 0 while I is less than primes.length I plus plus. All you do is for int p in primes, do this. Now that is ridiculously simple. So it's a great thing to have. It can really reduce a lot of code complexity, and it can avoid a lot of compile errors when you're like index out of range and index out of bounds. So it's a great thing to have in your back pocket. So here's another example. When before we had our sales clerks, right? So here we've got this dump data. We'll take a look at the code in a second. But instead of going through for each sales clerk, here we're just doing for sales clerk SC in clerks. So let's go take a look at the code and show you the difference between the two. So we wanted to look at the dump data method. So let's pull up the difference between the two things. And this is one of the nice things about this program is that you can look at them side by side, right? So there we go. So here we have dump data, and you can see here for int I equals 0, blah, blah, blah. And here it's simply for sales clerk SC in clerks. And we're saying, hey, if SC is not equal to null, because all reference objects get initialized to null when you declare it in an array, right? If it's not equal to null, then go ahead and print out its information, right? So we get name, get sales. Here you can see that we have to reference clerks by the index. So you can see how this code right here is more elegant than this code here, in my opinion. But that's just a way to show you the difference between the two and how you can use a for each loop instead of the typical for index or for loop. Well, that's it for the videos tonight. Hopefully you had a good first week of lecture. If you have any questions, make sure you write them down and bring them to class so we can get those questions answered. Or feel free to text me, call me, whatever you need to do. We'll be going through some exercises in class for week 1, looking at some of those sorting algorithms. Again, because I know it can be kind of, when you're not used to dealing with the indexes, and you've got 8 I's and J's, and you're minusing one and plussing another, it gets really, really hard to keep that all contained in your mind. So it gets better with practice, and you can start looking at things, but it really helps it to, when you're first learning it, to write it down and just walk through maybe like a small set of examples, just like, maybe an array of 5 items, and just to walk through it yourself to make sure that you're understanding what's going on and drawing out, what's happening inside the array, because it can be a challenge to wrap your mind around those things. So I understand it. Don't worry if you're looking at it going, man, this just seems crazy. Some of you might look at it and go, yeah, this is easy. It really just depends. So just hang in there. After this, it gets less into it's more straightforward with the discussions. It's more about how we can better improve our code and the things that we can do to make our code more resilient and more robust. So hopefully you enjoyed the videos. And again, if there's any problems, be sure to let me know so that way I can get it fixed for the next time the class is offered. So thanks. Have a good night.